So, um, have you ever tried balancing on a seesaw with a toddler?
Oh, yeah, that is always a bit of a challenge.
Right, because I actually attempted this last weekend with my little niece, and it was ridiculous. I was sitting there completely grounded on one end.
And she was just suspended way up high in the air, I bet.
Exactly. To get the whole setup to actually synchronize, I had to scooch all the way up right next to the pivot point.
You have to drastically shift your center of mass just to make the mechanics work.
Yeah, it looks totally absurd, but it really is a perfect little playground physics lesson for today's deep dive.
Mm.
We are jumping into our source material on Barycenters to show you how the universe operates as this beautifully synchronized system.
And that seesaw analogy really translates directly to how orbital dynamics function on a macro scale.
Right, because we usually just assume things orbit a fixed point.
Exactly. We assume a smaller body just simply revolves around a stationary, larger one. But gravitational forces are mutual. Both bodies actually orbit a shared center of mass, and that is the barycenter.
So it's not an actual physical object then.
No, it is a mathematical dynamical point in space dictated by the mass and distance of the objects involved.
Okay, let's look at how that applies to our own neighborhood. Given the mass difference between the Earth and the Moon, where does that shared point actually sit?
For the Earth-Moon system, the barycenter is located roughly 4,671 kilometers from Earth's core.
Wow, okay, so since Earth's total radius is about 6,371 kilometers, that means way.
It means that center of mass is situated roughly 74% of the way from the core to the surface.
So the pivot point is literally inside our own planet.
Exactly. As the moon orbits Earth is simultaneously revolving around that internal point, which creates this gentle, localized spatial displacement.
A wobble, basically.
Yeah, a very elegant wobble.
So our planet is constantly shifting its position in response to the moon's pull. Speaking of optimizing systems and finding that exact center of mass, it reminds me of trying to find the perfect efficiency point in a workflow.
Finding the right balance is crucial.
It really is. And our sponsor, Silk, helps you uncover where AI agents can make the most impact for your business or personal life. If you need help with AI training or automation or integration or software development, you definitely want to check out embersilk.com for all your AI needs.
It is all about finding that optimal pivot point.
Exactly. So getting back to the physics here, what happens to the dynamics when two celestial bodies are much closer in mass? Like when there isn't that massive disparity we see with the Earth and Moon.
Well, the entire geometry changes. If you look at the data on Pluto and its largest moon, Charon, you see a completely different dynamic.
Because Charon is pretty huge compared to Pluto, right?
Right. It has about 12% of Pluto's mass. Because of that relatively narrow mass ratio, the barycenter is pulled completely out of Pluto.
So it just sits in the empty space between them.
Exactly, roughly 960 kilometers above Pluto's surface.
Meaning neither body is truly central.
No, they mutually orbit this invisible point in the void.
Which basically makes them a binary dwarf planet system instead of a standard planet and moon setup.
Yeah. That is the formal classification many astronomers argue for, actually. It establishes a strict equilibrium. And while mass is a primary factor, the distance between the bodies exerts an equally profound effect.
Okay, if distance has that much influence, how does that scale up to the entire solar system? If the moon pulls Earth's center of mass 74% of the way out, what happens to the sun when you add the gravitational pull of a distant gas giant like Jupiter?
So the sun is over 1,000 times more massive than Jupiter, but Jupiter is located roughly 778 million kilometers away.
Which acts like a massive weight on the very end of a long seesaw.
Exactly. That extreme distance leverages the barycenter outward, placing the Sun-Jupiter center of mass at about 1.07 solar radii.
Wait, so Jupiter's gravity pulls the pivot point completely outside the sun?
It does, and when you calculate the combined gravitational vectors of all four giant planets, Jupiter, Saturn, Uranus, and Neptune,
their alignments drag the whole solar system's true center of mass around, right?
yes, often leaving it suspended just above the solar surface. The sun is essentially revolving around empty space.
That is just mind-bending to picture.
It is. And because planets pull their host stars into these subtle off-center orbits, astronomers use this exact phenomenon to discover hidden worlds light years away.
Oh, using the radial velocity method, right?
Exactly. By measuring slight color shifts in a star's light caused by its movement around a barycenter, we can detect the presence of exoplanets we can't even see.
It just proves that even the smallest unseen distant bodies have a profound, measurable pull on the giants of our universe. What a beautiful, optimistic thought to leave you with. What unseen positive connections are gently pulling on you in this grand, interconnected universe?
It is a brilliant, inspiring perspective. We are all part of this beautifully balanced cosmic dance.
Beautifully said. If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.